So, natural log integration, this is something we've been talking a little bit about. Hopefully you guys are really getting the hang of identifying and recognizing, oh, when it's 1 over x, you don't change it to x to the negative first and then try to integrate that, because that will be x to the 0 over 0, right? It's really equal to natural log of absolute value bars of x plus c. And I'm getting better too about making sure I put the absolute value bars there. Those are actually very important because they say that you can now plug in negative numbers as well. So make sure you do that. Or if you're doing in the middle of u substitution, of course, it's going to be all the same stuff, but with u instead, right? So let's just do a few practice problems of this. I'll just go through these kind of quickly because this wouldn't be, u is going to be 2x plus 5, right? It's the denominator here. So du is going to be 2dx. So dx is going to be 1/2 du. So when we integrate, this is back to indefinite integrals, right? Where there's no bounds on the top and the bottom. So indefinite integrals. And so we get 1 over u, 1 times 1/2 du. And that's going to be, so we have the 1/2 out in front, natural log of u. Of course, we want to then plug back in. Instead of u, we're going to plug in 2x plus 5 and make sure you have the absolute value bars there, plus c. So that's going to be our answer there. Just that, oh, should we factor it? Should we do? And you'll notice you actually can't. I don't think you can. You can't factor that. So let's just try and see what happens. And this might be one where we try one and come back and try another, right? But if we do this, this actually will work out. So let's take the derivative. I'm going to take the derivative of each of these, so it's 2x times dx plus 2 dx, right? And so we have more than one dx, so we need to factor this out, right? So 2x plus 2 dx, that's going to be du. So we get that dx is going to be 1 over, now I'm going to factor out the 2 as well, and if you look at the equation, you'll see why I do that. See, I'm trying to get the x plus 1 so it can be simplified. Can it be simplified? Can what? Can it be simplified? Can it be simplified? I'm not sure, Logan, what you're, well, let's go a little further and we'll see if I answer your question, okay? So I don't think the denominator can be factored, so I don't think it can be simplified. I could be wrong in that. If it could be simplified, then yeah, you would be allowed to simplify it, but I don't think in this case it's able to be. So we get integral of x plus 1 all over u, makes it look nicer at first, times 1 over 2 x plus 1 d, oh, I wrote dx, I meant to say du, right? du, okay? And now you see why x plus 1, why I factored that out, because we found the x plus 1, that can divide out with the x plus 1 up there. And so it's just like the same as before, right? 1/2 times 1 over u inside the integral. So we're going to get 1/2. 1 over u becomes natural log of u plus c. And of course, we want to change this to natural log of plug in x squared plus 2x minus 5, all inside the absolute value bars, plus c. And I'll go until you can write this down because this is the correct guess. Yeah, u is natural log of x, so we take the derivative. Du is going to be what? Well, it's 1 over x times dx, right? Chain rule, so you multiply at the end. So that means what? That means that dx equal to x times du, and you'll see, that's good because we have the x's in the right spot to divide out. So integral of 1 over x times u times x du. So those two x's are going to divide out, which is good because we need it just in terms of one variable. So integral of 1 over u du is going to be the natural log of the absolute value of u. And then we just plug that back in, which looks really weird. Natural log of the natural log of x. there's a sign there, and let's hope that this gets eliminated. So u is cosine of x. That means du is going to be negative sine of x times dx. And so dx is going to be what? It's going to be 1 over negative sine of x du. That's good because we have the sign in the numerator in the problem and sign in the denominator in our differential. So integral of what? Hold on, shift, that's a straight line. Sine of x over u times 1 over negative sine of x du. Yay, those divide out. We get a negative 1 over u. So we really just get negative natural log of the absolute value of u. And of course, we got to plug it back in, so we get negative natural log of the absolute value of cosine of x. All right, which is really weird, right? Like, we have what? The derivative and the integral of sine and cosine is just sine, cosine, and sine, right? Sometimes with the negative thrown in. And we can take the derivative of tangent, secant, cotangent, cosecant, and they become other trig functions, right? Which is a little weird, but it's, kind of normal. But taking the integral of those, tangent, secant, cotangent, cosecant, remember, we found like the integral of secant squared is tangent, but the integral of tangent is going to be something else different. And this is it right here, right? Negative natural log of cosine of x plus c. And so if you look down here in the box, this is the next thing we need to memorize, okay? So I'll put this in blue. Memorize, it's in a blue box, right? Memorize this. This is, make flashcards, right? I'll be honest, I'm memorizing them right now too, okay? I'm gonna write them on my wall, put some flashcards. Yeah, so I gotta get these down as well. So some of them, patterns you can see. I mean, any patterns you can see that help you out. Tangent, cotangent. And there's a natural log of all of them, right? Tangent becomes the negative, cotangent is a positive. Yeah, it's a big mess. If I figure out some good mnemonics or something to help you out, if anyone has one, let us know. But for now, it's just straight memorizing these. So let's just practice using these 4 things, and then I'll let you guys start your homework hopefully early. Maybe not. We'll see. All right, let's go with this. So we still need to do u substitution because we have 5x inside of that, right? So let's make u be 5x. Du is 5 dx, so dx is going to be 1/5 du. So we get the integral of tangent of u times 1/5 du. And so we're going to use the formula we actually just found. So it's negative natural log of the absolute value bar of cosine of u plus, times 1/5 plus c, right? I could have put the 1/5 at the beginning. Maybe I will in this next line. And so don't forget, after all that, we still have a u in there, right? So make sure you substitute that back out. So negative 1/5 natural log of the absolute value of cosine of 5x plus c. All right. I just skipped the step. I went ahead and plugged in u all in one step. Let me know if you need to see that other one. But yeah, 1/5 natural log of secant of 5x plus tangent of 5x, all inside absolute value bars, plus c on the outside. All right, for the next one, we'll work on this one together. It's, well, inside, you do want 4x squared to be in there. And of course, when you take the derivative, you'll have an x, and that's what that x out there is for. That will undo that one, right? So du is going to be 8x dx, 1 over 8x du. I'm running out of room. All right, integral of x cosecant of u, 1 over 8x du. X is divided out. So cosecant is going to be negative natural log of cosecant of u. It's cotangent of u. I don't blame you if you don't want to write all that out and just go ahead and plug in what u is. That's fine too. Do that here. U is tangent of x, so du is going to be secant squared of x dx. Oops. I have my nose up here. Where'd that go? Oh, did I? Oh, all right. So then what? So dx. Oh no. dx, there we go. 1 over secant squared of x. I'm going to leave it like that. I know we could change it to cosine, right? Squared of x, but oops. Leave it like that because that will get that eliminated. So we have the integral of u in the denominator, secant squared of x, and 1 over secant squared of x du. Those divide out. So get natural log of u. And so we get natural log of the tangent of x. So I guess this one's in here to show you guys just because there's tangents and secants doesn't mean that you have to use these rules, right? I just realized we didn't even use any of the rules in the box, right? This was actually an old problem that we could have done from way back. Make sure my notes on it. One other way to approach this, which I don't know if anyone tried this on their own, is you could try to simplify. Secant squared, that's 1 over sine. Tangent is sine over cosine. But if you do that, and my notes are not pulling up here, but I'm pretty sure what you get is something that's not, you can't integrate. Yeah, because it's 1 over sine times cosine or something like that. And so, yes, that ends up being a dead end. So what we did there was what is possible. Yep, cool. All right. For the next one, instead of doing u substitution, we're going to try something a little different. I'm going to pause and ask this question. What does 1 plus tangent squared of x make you think of? So you should, and it shouldn't be, if you haven't memorized, great. If it's not something you have memorized, you should at least recognize it, right? And be like, hey, I know it's equal to something. I can find out what it's equal to by this little thing here, okay? So let's replace that. Notice that we are not doing u substitution, so we're not changing the variable of integration. It's still an x. So we don't need to change the, do not need to change the bounds, okay? We're going to leave that there. Let's just change it to secant squared of x dx. And, yeah. So the square root of secant squared is just going to be secant, right? Now, how much do I want to talk about this? Secant is 1 over cosine, which is an even function, right? And so technically, if you take something and you square it and you square root it, it will be positive. Since secant is even, though, it doesn't matter whether it's positive or negative. Let me pause. What I'm saying, like if you take something, you say heck, x squared, square root of that, whatever you plug in here, if you plug in a negative number, it's going to become positive, right? And so technically that's not equal to x, that's equal to the absolute value of x, unless it's an even function already, where, remember, even is where when you plug in a negative or positive, it doesn't matter, you get the same value. So this technically, yeah, we don't have to worry about that, all that to say, this is fine, just keep going with this. Now we can integrate it using our formula. So we get what? The natural log of the absolute value bar of secant of x plus tangent of x, evaluated from 0 to pi over 4. Tangent x, yeah. So what does that mean? That means we've got to plug in pi over 4 both places, and the subtract plugging in 0 both places. Notice we don't have plus c. We don't need plus c because it's a definite integral. It's not an indefinite, right? So let's plug those in, and here's where I'm going to ask you guys, what is secant of pi over 4? What is tangent of pi over 4? What is secant of 0? And what's tangent of 0? So let me pause that. A refresher, I would draw, oops, for the pi over 4s, 1, 1, root 2. So secant pi over 4 is going to be the reciprocal of cosine is hypotenuse over adjacent, so root 2 over 1, which is just root 2, so natural log of root 2. Tangents, opposite over adjacent, 1 minus, for this one, I remember that cosine of 0 is 1. Secant's going to be the reciprocal of that, so that's going to be 1. Tangent sine over cosine, sine of 0 is 0. So tangent of 0 is 0, so that's going to be 0. So you get natural log of 1 plus 0, which is just the natural log of 1. Natural log of 1 asks e to the what power equals 1? E to the 0 power equals 1, right? So remember, natural log of 1 equals 0, so that whole thing is going to be 0. So we just get natural log of the square root of 2 plus 1. You can't simplify that anymore because that addition kind of locks those in there, right? There's also no plus c on the outside, though. If you put a plus c, that would be incorrect. I just looked at the time and realized we only have 4 minutes left. So let's hustle through these next few. I'll go and share. You would probably guess u should be e to the negative x, and you would be correct. Du is going to be negative e to the negative x dx. And so when we get this, we have dx is negative 1 over e to the negative x. I know e to the negative x is e to the positive x, but I'm leaving it like this just because it's going to divide out very quickly and nicely right there, right? So we get what? We get the integral of e to the negative x cotangent of u times, I'll just put negative 1 over e to the negative x. And now those e to the negative x's divide out. If you want to write it as e to the x and then divide it out, that's great too. So cotangent of u. What is cotangent of u? Cotangent of u is natural log of sine of x. And we already have a negative in here. There's no negative in the from the integral itself. There's a negative inside this specific problem. So it's going to be negative natural log of sine of u plus c. Don't forget your plus c again. And so when we substitute the u out, natural log of sine of e to the negative x. That reminds me of a good knock-knock joke. Find the average value. So we're doing average value. You should be thinking, hey, 1 over the bounds, right? 1 over the difference of the bounds. So we're going to have the integral from 0 to pi over 4 of tangent of x dx. But to find the average, we want to multiply by 1 over pi over 4 minus 0, right? And so, yeah, so this is just an interesting question if we have time to develop it. It's like, okay, what is the average of tangent, even though it's going like crazy up and down, right? From 0 to 0 to pi over 4. What's going on there? But anyway, let's calculate this, and we have time. We can look at the graph. So what do? We leave that 1 over pi over 4 in front, or you could even flip it. We'll flip it on the next one, 4 over pi. And tangent, remember, is natural log of a negative natural log of cosine. So times the negative natural log of absolute value bar of cosine of x. We don't need a plus c because we're evaluating this function from 0 to pi over 4. So, oh, what? The bell? Ah! Okay, let's finish this real quickly. 4 over pi, it's going to be negative, right? And we get natural log of, now I'm gonna put this part in parentheses. So cosine of pi over 4 minus natural log of cosine of 0. Well, what is cosine of pi over 4? That's going to be 1 over the square root of 2, right? Or root 2 over 2. Either way is fine in calculus to write it. Minus, oh, sorry, I forgot the natural log. Oh, sorry. Natural log of 1 over root 2. Hopefully you have space to write that in there. Minus natural log of 1. Well, we just saw earlier, natural log of 1 is just 0, right? So you want to make sure, put that in there. That's just going to be 0. So we get negative 4 over pi, natural log of 1 over root 2, and we can end our day there. All right?